Ever wondered how a solar eclipse would look if you were standing on Mars? This is a question that's likely never crossed your mind, yet it's one worth exploring. To do so, we will need to delve into various celestial phenomena and dissect certain scientific principles. First, let's take a quick refresher course on what a solar eclipse is. In the simplest terms, a solar eclipse is a celestial event that takes place when the moon slips between the sun and the earth. The moon temporarily blocks the sun's radiant light, casting shadows on certain parts of the earth. This alignment of the sun, the moon, and the earth creates a sight of mesmerizing beauty, one that has baffled and fascinated humans for thousands of years. However, the solar eclipse is not the only eclipse that captures our attention and wonder. There's another celestial event that's equally intriguing, a lunar eclipse. This happens when the earth positions itself between the sun and the moon, causing the shadow of the earth to fall on the moon. This interaction gives the moon a peculiar reddish appearance, commonly referred to as the blood moon. At this point you might be questioning why we're discussing Earth's eclipses when our focus is supposed to be on Mars. The answer is simple. Understanding the basics of eclipses here on Earth helps lay a solid foundation. From that foundation, we can then apply and expand our knowledge to other celestial bodies like Mars. Earth has one moon. Mars, however, isn't limited to just one. It has two moons, Phobos and Deimos. These Martian moons are smaller than our moon, and they orbit much closer to Mars, whirling around it in a much tighter circle. The mechanics of a solar eclipse remain the same regardless of where it's observed. One celestial body passes in front of the sun, seen from another body. However, the variance in size and distance of the moons will mean the experience of a solar eclipse on Mars would be unique, quite different from what we're accustomed to seeing here on Earth. Let's set our imagination in motion and paint a vivid picture. Imagine standing on the barren, dusty red surface of Mars. The sky, not blue like here on Earth, but a pinkish hue reflecting off the iron-rich surface. The sun shines brightly, a smaller-looking orb in the Martian sky. Then, from the horizon, one of Mars's irregularly shaped moons begins to creep into view. It moves slowly, sliding across the sky, gradually inching its way towards the sun. The tension builds as the moon makes its steady progress. Now let's transport ourselves to the dusty red surface of Mars and imagine how a solar eclipse would look there. Solar eclipses on Mars are quite different from what we're used to seeing here on Earth. Let's dive into the science behind this fascinating celestial phenomenon. Just like on Earth, a solar eclipse on Mars occurs when one of its moons passes between the sun and the planet. However, the Martian moons, Phobos and Deimos, play a significantly different role in these events than our moon does here on Earth. Phobos and Deimos are much smaller than our moon. Phobos, the larger of the two, is only about 14 miles in diameter, while Deimos is even smaller with a diameter of just over 7 miles. In comparison, our moon is a whopping 2,160 miles in diameter. Due to their small size, Phobos and Deimos can't completely block out the sun as our moon can. Instead, they create a different kind of solar eclipse known as a transit. During a transit, the moon passes in front of the sun but doesn't cover it entirely. The result is a small dark spot moving across the sun's face, rather than the complete blackout we're used to seeing during a total solar eclipse on Earth. The frequency of these transits on Mars is also quite different. Phobos, being closer to Mars, transits the sun several times a Martian day, while Deimos, being further away, does so only once every 2 or 3 days. This means that if you were standing on the surface of Mars, you'd get to witness this unique spectacle much more frequently than we do here on Earth. So there you have it, the science behind solar eclipses on Mars. It's a fascinating blend of astronomy and planetary science, showing us yet another way in which our solar system is wonderfully diverse. If we were on Mars, we wouldn't see the complete blackout that we associate with solar eclipses on Earth. So what exactly would we see during a solar eclipse on Mars? Well, imagine standing on the red planet's surface, looking up into the sky. The sun is shining bright, casting a warm orange glow over the Martian landscape. Suddenly, a small black dot appears on the sun's face. The dot grows larger, gradually taking a bite out of the sun's luminous disk. But unlike a solar eclipse on Earth where the moon completely covers the sun, this black dot doesn't swallow the sun whole. Instead, it continues its journey across the sun's face, leaving behind a sun that's been nibbled at, but not entirely consumed. This black dot, my friends, is either Phobos or Deimos, Mars' two moons, causing what we call a Martian solar eclipse, or as scientists like to call it, a transit. Phobos, the larger and closer of the two moons, casts a larger shadow and thus creates a more noticeable eclipse. Deimos, being smaller and further away, appears as a tiny speck against the sun. Now here's the interesting part: solar eclipses on Mars are quite common. How so? It boils down to the moon's orbits. Phobos orbits Mars about 3 times a day, and Deimos does so in about 30 hours. This quick orbiting means that from any given point on Mars you could witness multiple solar eclipses within a single Martian day. That's quite a celestial show, isn't it? However, despite their frequency, Martian solar eclipses are not as dramatic as what we see here on Earth. The sun is not entirely obscured and the sky doesn't darken dramatically. There's no breathtaking corona, no diamond ring effect. Instead, it's a subtle, almost understated event. A small black dot leisurely tracing a path across the sun's face. Solar eclipses on Mars are more frequent yet less dramatic than what we experience on Earth. But they are still a fascinating spectacle, a celestial dance that underscores the uniqueness of each planet's relationship with its moons and the sun. Did you know that our Martian rovers have actually captured these solar eclipses? Quite an incredible feat, isn't it? These rovers, including the likes of Curiosity and Opportunity, act as our eyes on the red planet, enabling us to witness solar eclipses from a perspective no human has yet experienced firsthand. Let's take the Curiosity rover, for example. It's been diligently exploring the Gale crater on Mars since 2012. During its journey, it's had the unique opportunity to photograph not one but 2 of Mars's moons, Phobos and Deimos, as they passed in front of the sun. These images, taken by a machine millions of miles away, are not just stunning to look at, but they also provide invaluable data to scientists back on Earth. Now let's talk about Opportunity. This rover had a rather long stint on Mars, running from 2004 until 2018. During its mission, Opportunity managed to capture images of Martian solar eclipses too. It's thanks to these rovers that we've been able to study these celestial events up close and without the atmospheric interference we deal with here on Earth. These captured images have been instrumental in helping scientists learn more about Mars's moons and their orbits. For instance, they've revealed that Phobos, the larger of the 2 moons, is slowly spiraling inward towards Mars. It's expected to either crash into Mars or be torn apart and form a ring around the planet in about 30 to 50 million years. In contrast, Deimos, the smaller moon, is slowly moving away from Mars. These observations have given scientists clues about the inner workings of Mars and its gravitational pull. So, while we may not yet be able to stand on the Martian surface and gaze up at a solar eclipse, we have the next best thing. Our rovers, these tireless explorers, continue to capture the wonders of our neighboring planet, bringing us closer to understanding the mysteries of the universe. Thanks to our rovers, we have a front row seat to these Martian phenomena. So, a solar eclipse on Mars might not be as dramatic as what we see on Earth, but it's still quite a spectacle. It's a celestial ballet with the Martian moons Phobos and Deimos playing the lead roles. These tiny moons, compared to our own, cast their shadows on the red planet, creating a spectacle that is uniquely Martian. We've delved into the science behind these events, seeing how the size and proximity of Mars's moons create an eclipse that is different from what we see here on Earth. These are not total eclipses plunging Mars into darkness, but rather, they are transits. The sun remains visible, but with a small dark silhouette of a moon passing across its face. We've also explored the perspective of the Martian rovers, our mechanical emissaries on the red planet. These rovers have captured images that give us a glimpse into these Martian solar eclipses, a sight that for now remains beyond human reach. The images they capture are more than just breathtaking visuals. They provide valuable data for scientists to study the atmospheric and environmental conditions on Mars. Understanding these solar eclipses on Mars has significant scientific and exploratory implications. They help us learn more about the Martian atmosphere, the behavior of its moons, and provide unique opportunities for scientific observation and discovery. Every image, every piece of data, brings us one step closer to unraveling the mysteries that Mars holds. These Martian solar eclipses are not just events, they are moments in time that encapsulate the beauty and wonder of our universe, the curiosity of human spirit, and the ceaseless pursuit of knowledge. They remind us of how much we've achieved and how much more there is to explore. And who knows, maybe one day, humans on Mars will be able to witness these solar eclipses in person. Until that day comes, we'll keep exploring, keep questioning, and keep marveling at the wonders of our solar system.